of institution. All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
The center is set up among Taiwan Tech, ITS, and Vidya Mandala Catholic University, Surabaya. The main goal of the center is to strengthen cooperation on science and technology between Indonesia and Taiwan, and we will focus on recycle and reuse of industrial waste. Targeted compounds include fly ash, burning slag, and spent bleaching aid that are of significant amount and to our common interest. It will also involve 1,400 strong alumni in Indonesia, and we will engage private sectors, NPOs, and research institutes.
Through this international collaboration, Institute Technology 10 November could strengthen the collaboration between National Taiwan University of Science and Technology, Vidya Mandala Catholic University, and Indonesian Institute of Science. This research center was developed as a platform to connect the researchers from different universities from ITS, Vidya Mandala, LIPI, and NTUST with the experts from industry that work together to have the research regarding to the eco-green solution and for the circular economy and sustainability. Waste utilization is one of the implementation of eco-green solution, and we know that Indonesia could be develop this model to recover of the waste and use as a many different purpose, and also we can develop a good impact to the environment and also to the society.
We are proud that IPS, the Institute of Technology 10 November, Surabaya, Indonesia, has been a part of this prestigious international collaboration. The topic of circular economy and green innovative resource matches with the IPS vision and the world focus. So I believe that the research center opens opportunities for researchers to expand the outcome, the connection, and also the international collaborations. In addition, it boosts the ITS contributions to the nation.
Besides a medium to the international research collaboration, this research center wants to provide a database experts from Indonesia and Taiwan so they can find a sparring partner to work together for international research collaboration. By this research center, we do hope that the spirit of doing research and innovation for Indonesian academia can grow and we can have a broader link for collaboration in international scale. And when a new researcher come up, they can use this platform to build collaboration for their research and also support their career. It is a great pleasure that scientists and engineers from Indonesia has a place to work together to build a collaboration with other countries, especially Taiwan. This is a proof that Indonesian researchers can work together and compete with others in the world-class research. Lembaga Ilmu Pengetahuan Indonesia, or we call LIPI, support the research center, and together we can solve industrial problems, especially for waste treatment and reuse. Through Taiwan Indonesia Research Center, we can build triple helix research by connecting government, university, and industry.
As a rector of Vidya Mandala Surabaya Catholic University, it is my great honor to be part of Taiwan Indonesia Research Center to promote international collaboration in order to develop the innovative ideas from Indonesian academia for Indonesia circular economy.
Indonesia needs intensive construction as a modern and developed country. And we know that the source of waste, especially from industrial waste, is abundant in Indonesia. We can use this waste for utilization, and also this is a small step that we can use as an eco-green solution. For example, we have produced a lot of food slugs that can be used as a cement additive and also for construction. We also produce a lot of spent bleaching earth that can be used for cement making and also for the adsorbent.
We already structured STIC roadmap based on our goal, which is circular economy and green innovative resource. In the first year, we established a platform for the collaboration of industry, academia, government administrator. And it followed by a data bank of experts to support potential collaboration and capacity building in the second year. And in the third year, we focused on expanding this collaboration as well as capacity building through seminar, workshop, and exhibition. STIC CEGIR also cooperate with Minister of Science and Technology Taiwan and Taipei Economic and Trade Office as Taiwan representative in Indonesia who fully support this center. The Science and Technology Innovation Center raised two main issues, namely circular economy and green innovative resource. The goal of this center to strengthen the cooperation on science and technology in line with new southbound policy of Taiwan government.
Be better together. Together, be greener. Thank you.
Welcome to the Policy and Implementation of Circular Economy, Challenges and Opportunity 2021 Virtual International Seminar in conjunction with the virtual opening ceremony of Taiwan Indonesia.
Okay, good morning, everyone. Okay, we will start our webinar today. Assalamualaikum warahmatullahi wabarakatuh. Good morning, all of the participants. My name is Warma Dewanti, and I will be the Master of Ceremony of this event. And the Honorable Director of Vidya Mandala Catholic University, there as Kunchoro Foy, GDIP SA PhD. Selamat pagi Pak Rektor. Masih di perjalanan saya kira ini.
Selamat pagi ya, terima kasih.
Terima kasih kehadirannya pada pagi hari ini Pak Rektor.
Terima kasih sama-sama semuanya.
And also the Honorable.
Pagi seluruh peserta.
Selamat pagi Pak Rektor. And Honorable Professor G.C. Liu, the Director of Science and Technology Innovative Center for Circular Economy and Green Innovation Resources, and also the Vice President of the National Taiwan University of Science and Technology. Good morning, Professor Chào An.
Good morning. Selamat pagi. Okay, nice to meet you all. Thank you.
Nice to meet you again, Professor. And also, the Honorable of Distinguished Professor Huang Cholung. Professor Huang, good morning.
Yeah, good morning. Terima
Nice to
kasih.
meet you again. And I think this is a lot of alumni from construction engineering is also come to this event, Professor Huang.
Yes.
Yeah.
Yes, yes.
And we have the General Manager, Amos Chang.
Good morning, everybody.
Good morning. Good morning, Mr. Amos Chang. And General Manager Amos Chang is from Chung Tai Resource Technology Corporation. Thank you very much for coming today. And also we have Ibu Dr. N. Januarti Jaya Eka Putri. Ibu Dr. Januarti, selamat pagi. Ibu Januarti is from Civil Engineering of ITS. And also we have Ibu Felicia in here and Dr. Jenny, Dr. Dian, and all of the participants today. We will start our webinar. Before we start it, I would like to introduce a little bit about our research center, as already mentioned previously by the video. And this webinar today has a themes of recovery and recycling of waste from industry. And the webinar conducted under Science and Technology Innovative Center for Circular Economy and Green Innovation Resources. This is the collaboration between the National Taiwan University of Science and Technology with the Widya Mandala Catholic University and also with the Research Center of Infrastructure and Sustainable Environment of the RPM of Institute Teknologi 10 November. And on this event, our agenda today, the first one is opening. We already have the opening in this morning and then continue by the speech from Professor G.C. Liu as the Director of Science and Technology Innovation Center for Circular Economy and Green Innovative Resources. And the third one is welcoming speech and opening from the Rector of Vidya Mandala Catholic University. And then we are continue by the main agenda, the explanation of each topic by each of distinguished professor and also honorable speakers. So without overdue, I would like to invite Professor G.C. Liu to have some speech in this webinar event. So Professor Liu, the time is yours.
Thank you very much, dear Wawa. Again, good morning, 早安, greetings from Taipei. We are really honored to have distinguished speakers, two from Taiwan and one from Indonesia. We are very happy to have Professor Emeritus, Professor Huang Zhaolong, a highly distinguished expert and scholar on resource recovery, particularly when apply and reuse it for construction purpose. We are also very honored to have General Manager Mr. Zhang, who represents Zhongtai Resource Corporation, which is a model corporate in Taiwan, known for circular economy. And also we are happy to meet and have the opportunity to have Ibu Januarti to share her precious experience with us. I hope everyone happy and this webinar is very fruitful and successful. Thank you very much.
Thank you very much, Professor Liu. Yeah, and then for the second speech, we would like to invite Rector of Vidya Mandala Catholic University, Dr. S. Kunchorofil G. Deep SAN, Diploma SA and PhD, to give the welcome remarks and also opening this webinar today. So, Pak Kunchorofil, the time is yours, Pak Rector.
Thank you very much for the MC, our distinguished guests, ladies and gentlemen, especially Professor Liu, as the director of the STIC. First of all, I'd like to congratulate all the team of the STIC CEGIR, Taiwan Tech, ITS, for their fruitful collaboration in establishing the very meaningful and I think the very important center to respond the challenges faced by every single individual on this earth nowadays. So that's about the global warming, about the waste. Therefore, this workshop entitled The Recovery and Recycling Waste from Industry as the main vision and mission of the establishment of this center, I think is very critical, as this workshop is expected to become a medium for transferring technology and knowledge regarding recovery of fly ash and bottom ash produced from Taiwan industries and technologies to recovering and recycling industrial waste in Taiwan. Therefore, on behalf of all the participants, I'd like to express our sincerest gratitude and highest appreciation to all the distinguished speakers in this morning. As mentioned by Professor Liu, that is Dr. Eng Januarti Jaya Eka Putri, Professor Emeritus Huang Chaolung, and also the Mr. Amos Chang, General Manager of Chung Tai Resource Technology Corporation. And of course, to all participants who have joined this workshop, I do appreciate all your attendance in this very important workshop, as this demonstrates the very highly responsible manner for all of us to do our best in managing the waste surrounding us, and of course the good practice phase has been responded and researched by the Taiwan experts and also Indonesian experts will be beneficial for all of us. And finally, I'd like to invite all of you to continuously collaborate, cooperate, because together we can do everything. And that's, I think, the main message of the establishment of the STIC, that the Taiwan government has invited all the neighboring countries, especially in Asia Pacific region, to respond to global issues. Therefore, I'd like to congratulate Professor Liu and also all the support donors and also, of course, the Taiwan government for this kind of initiative. So on behalf of all the participants and also the Professor Liu as the director of the STIC and all distinguished speakers, I formally remark the opening of this workshop today, organized by the STIC CEGIR. I wish all of you the best and can attend this very important workshop from the beginning till the end, so we can also the take-home message upon the completion of this workshop, we can do something better in the future. Together we can do better and make this earth and our place a better place to live. May God bless you all. Thank you very much.
Thank you very much, Pak Rektor. Thank you for the opening remarks today. And we really hope that this webinar also can be successful and come up with a good discussion. Thank you very much, Pak Rektor.
A great pleasure.
Yeah. So before we start our main agenda, I would like to mention to all of the participants, we have the interpretation in here. So if you check your Zoom meeting, you can see in the bottom part, they will be show the interpretation. If you choose in English, so you will be hear this webinar in the original one. But then if you choose Bahasa, so you will be, or Indonesian, you will be hear the Indonesian language. And later on, we will also have the Chinese one or the Mandarin ones, then it will be translated in bahasa. So, Bapak dan Ibu sekalian, untuk kesempatan pagi hari ini, Bapak dan Ibu bisa melihat di Zoom meeting-nya itu ada interpretasi atau interpreter. Karena kegiatan ini akan menggunakan bahasa Inggris, interpretasinya ada di dalam bahasa. Apakah sudah bisa terlihat, Bapak dan Ibu sekalian? Jika Bapak dan Ibu ingin mendengarkan dalam original atau dalam bahasa Inggris, maka bisa memilih original audio. Sedangkan jika Bapak dan Ibu ingin memilih di dalam bahasa Indonesia, silahkan memilih dalam bahasa Indonesia, dan nantinya kita juga akan ada terjemahan dari bahasa Mandarin ke bahasa Indonesia. Semoga sudah bisa terlihat partisipan. Hari ini ada kurang lebih 100 partisipan. So, we come up with the main agenda, and I would like to invite the moderator for this session, Professor Felicia. Bu Feli, are you there?
Yes, I'm here, Bu Wawa.
Yeah, okay. So Bu Feli will be the moderator for Ibu Januarti Jaya Eka Putri and also Professor Huang Cholung. So the time is yours, Bu Feli.
Thank you, Bu Wawa. Good morning, ladies and gentlemen, distinguished professors. It's nice to be here, even though we are in the webinar, and we do hope soon we can meet each other in person. So before we start, the first session is Dr. Can we go? Okay, thank you. Dr. Eng Januarti Jaya Eka Putra. She is the lecturer in ITS and also have a background of education in civil engineering from ITP and then doctor degree from the University of Tokyo, Japan. She has many awards, such as the first prize of Mining and Mineral Industry Institute Research Award Competition 2019, and also silver medal from National Research Council of Thailand in 2020. She's a very productive lecturer and researcher, and we are honored today to have her to share her expertise for introduction. And then after her, we go to the second presentation is Professor Huang Cholung. I will introduce him later. So the first presentation, I give the time to Bu Januarti. The time is yours, Bu Januarti.
Thank you very much, Bu Feli. Good morning, everyone.
Morning.
Yeah, it is very nice day to start this today with a very good meeting. And it is my great pleasure to meet again Professor Liu and also Professor Wang. And yeah, we have, I think I have a good friend from Chuntai, yeah, Mr. Amos Chang. I think it's like a double, yeah, like a, yeah. Is that okay, Bu Feli? I listen some interpreter saying something. Should I just?
I think you can ignore it, Bu
Okay.
Let the interpreter interpret you, so you can present just like
okay.
no there.
Okay, okay, and it is coincidentally very happy to see Pak Kuncoro here, and I think I should report to Bu Warma. Yeah, Bu Warma. Last time I mentioned about our proposal, and we met a very good, like reviewers, and one of the reviewer is Pak Kun. So thank you very much, Pak Kun, for helping us.
I think I'm impressed with your matching fund proposal, Professor Liu. Yes, it's very good, So her dream to make a good research on waste is incredible. I have to give credit to her.
Thank you
Yeah.
very much.
Thank you,
You
Pak
give us a very
Kuncoro.
good mark. So
Yeah, this
Yeah, I hope-
reunion for 2 weeks ago
yes,
at
thank
4
you.
Points
And,
Hotel in Surabaya.
yeah, like Professor Liu, at that moment, I didn't know who is he. I didn't know that he's a famous person from Mandala University. I'm so sorry. I just asked him
No
like,
worries.
who are you, sir? Okay, no, your name is Kuncoro, and then where is your university? It's kind of like very rude greetings. But yeah,
Yeah. So what
I
a small world, you know?
yes. Okay. Yeah. Yeah. I should start my presentations. I will share my file. Okay. Is that visible now?
Yes, we can see it. Maybe the slideshow.
Yes.
Okay, that's great.
And yeah, this is we have a FABA application. We call it FABA Fly Ash and Batamas application for Indonesian green belt. This means that we need to protect our coastline, our beach, our infrastructure in the coastline by using FABA utilization, FABA or collage. And let me share you my experience during my maybe more than 20 years on concrete durability research. And this accident happens in Amurang Beach in North Sulawesi, and it occurs because of the abrasions. Okay, I will play the video. Just very recent, yeah, June 15. So you can see here, there is no protections. There is no breakwater. And all buildings here collapse because of the abrasions.
Yes.
It's very sad because it was sent by my friend who is living there. So yeah, this is also scary. If we cannot do anything with that, what happened to the next? Yeah, and also the abrasion is very severe, but some parts can be safe because of very limited limited protections, very limited, and it is still okay. And next, this video can we can see here a house collapse. Yeah, the sound here is off because there are too many people scream. So I made it off. And we can see here is the Amurang Bridge.
Oh.
Where is the protection? What happened there? The bridge was built without any protection from the sea. So it's unbelievable. And another one, just go on like that. And what should we do? Yeah, then this is the one that we are concerned in the world, not only in Indonesia, but also in the world. We know that mangrove is the back protector for our coastline. And the situations of mangrove in Indonesia in a very bad conditions. And we know that also mangrove is a mainstay of CO2 capturing. We have to rely on the mangrove because it's a very important forest. And the problem here, how to plant the mangrove saplings is not in the correct way. They use PVC pipes to protect the mangrove saplings from the waves. and it failure like this, and all the saplings was washed away by the current wave, and we can see again and again they try to plan and fail, plan again and fail. It is we lost a lot of energy because of that. And this is from the Ministry of Environment, collaborate with the Ministry of another ministry who has the responsible for revitalization and rehabilitations, how the condition of the mangrove in a very critical conditions. We have to maintain and planting and to educate the people also for mangrove which are in the good conditions. We have to protect and utilize in balance. And this is the conditions of mangrove very near to our campus in Wonorejo. We can see here the failure, many failures of mangrove planting in east coastal area of Surabaya city. Why? Because we don't have any, I don't know how to say, good educations or good management of planting system. And from the right side, we can see a group of bamboo fences in Thailand. It is a project with I think Yokohama National University, because Professor Suzuki is my friend who is doing research in Thailand on mangrove. And they put layers of bamboo fences there with a very special shape. There you can see a triangular shape. And you can see some layers of the bamboo fences to protect the mangrove saplings very far away from these fences. And here again, this is the view of the Wonorejo Mangrove Eco Park. We took it maybe 2 years ago, and we went there. And actually, our target is to make it big, thicker, at least 250 meters forward to the seaside. And the condition is not good also. This is just a video from the drone 2 years ago. Yeah, this is, we can go there. I think maybe Professor Liu can go there to see and to enjoy the scenery in the Wonorejo, very near to IPS. And this is our idea, how to combine the mangrove as the live breakwater and with concrete blocks as the breakwater, as a structure to protect both, to protect the saplings and to protect the coastline. And this is the idea. And we can use fly ash and bottom ash, both of them, to make a breakwater, make a good structure and durable structure, durable concrete to protect our coastline. And we've made a simulations here, the eastward current, very near to Surabaya, and this is the north side. And in the simulations, we put a very small barrier here, a breakwater, and you can see this is the the current velocity. The current velocity, the red means 0. There is no current velocity. So by putting or by building, by constructing a very small breakwater here, we can see here the current from very high current can be reduced to 0. So this is the idea to put some breakwaters by using fly ash and bottom ash to protect Surabaya from the abrasions. And this is our research and our recent applications at ITS. As you can see here, making concrete is very simple. You just mix all cement, sand, gravel, and water. What is the difficult things to make a concrete? Everybody can make a concrete. But the problem here when we utilize fly ash, when we put biomass to the concrete, the properties change, and the mechanical strength also changes. But the durability, we know the durability will increase. Here, there are three methods to make concrete by using fly ash and biomass here. As a cement replacement, usually we use fly ash as maximum of 30% to replace cement. And we use also biomass to replace sand. And we use, we use also gravels and water. And the second method, if the quality of fly ash is very good, then we can replace cement at maximum of 80%. So this is very good because the price reduce also. Yeah, we can reduce the price, we can have a cheaper concrete, but here maybe the mechanical strength also reduce. Here we put microbes, we use bacteria, we use fungi to make a calcite precipitations in the concrete, to make our concrete becomes denser, and to increase the mechanical property of the concrete, to increase its tensile and to increase its compressive strength. This is the one that we are doing the research, and Warma here is one of our experts in our group. And the last one, the very famous one, is geopolymer. We don't need any cement Portland. We just use fly ash 100% to replace cement. And we use also biomass to replace sand, and we use gravels as usual, but we replace water with alkali activator. And talking about the difference between the geopolymer and conventional concrete here, we use fly ash 100% to replace cement, and we use alkali, usually we use natrium or sodium to replace water. And as usual, we can combine biomass and sand together with gravels to make a concrete. And the appearance is the same. The workability also is the same. The mechanical properties also the same. But talking about durability, geopolymer is a super material. So it can resist acid. It can also resist the chloride penetrations. It can resist blasting load, and also it can resist fire. So we can use this kind of material for fire protections. And this is one of the pictures we took from Tanjung Balai Karimun, one of the island very near to Riau Island. And we can see here that these piles has a lot of corrosions. We can also capture here a lot of barnacles. We call it biofouling. It's a very common phenomena in the beach and also in the coastal line. And corrosion will occur not only because of the chloride ion, but also the attack of the barnacles. So what should we do with this structure? And we know that the fly ash and biomass has a lot of benefits for structures, especially to increase its durability. Especially if we use geopolymer 100% to replace cement Portland with fly ash, it can enhance structure durability. And this picture was taken in one of the locations of piles in Suramadu Bridge at Madura Strait, East Java. You can see also here a lot of barnacles or biofouling attached to the piles. And we put our specimens very near here. We put our specimen, our concrete, geopolymer concrete, Of course, this piles was made from conventional concrete, but we put our geopolymer specimens very near to the piles. And this is the locations, and ITS is around here. ITS is around here. And here is the result. This is the maximum chloride ion, free chloride ion, standard by the, we have an Indonesian national standard to control the how much free chloride ion can be found in the concrete, and this is the maximum. When we put the normal concrete here in the immersions in the sea or water for at least like here like 4 months, chloride ion in normal concrete increased dramatically, and this point is just like a 7.5 centimeter in the depth of the concrete. So it means that the free chloride ion can go and penetrate into the normal concrete, and it can initiate the corrosions if we put a rebar or reinforce inside the concrete. And what happened if we use geopolymer and we put it in the seawater? It's very interesting here. We mix geopolymer not with water to make the alkali, but we use seawater to simulate that how severe the conditions if we don't have any tap water or clean water. We just use the seawater to mix the concrete, and this is the way we made our geopolymer, our first specimen. And we can see here it can entrap or immobilize the the chloride ion inside the matrix of the geopolymer. And for the second specimens here, we made our geopolymer. We cased our geopolymer, and one day after casting, we put it directly into the seawater. And what happened here? Again, the geopolymer can immobilize the free chloride ion very good. Yeah. So this is the very much difference, the durability of the from the normal concrete, how different the normal concrete from the geopolymer. All right, then I come up with the conclusions because I was given a very limited time. And as we can see here, for the green belt of Indonesian coastline, actually fly ash and bottom ash have contributed to many areas. It has a lot of benefits for our infrastructures in coastal area, and both fly ash and bottom ash can be used as a potential material to immobilize the chloride ion to protect our structure from corrosions. And again, mangrove as a barrier, life barrier can be combined with concrete blocks as a breakwater for coastal protection. Hello?
Oh.
Okay. So,
Thank
yeah, this is the
okay. Thank you.
The end of my presentations, and yeah, we shall go back to Bufel.
Okay, thank you, Januati, for the nice presentation, and it's quite terrifying video when the house is just collapsed by itself. I think we need really concern about environment and how the things safety and protection is really very important. So actually we have question here, but can we hold this one until we finish the presentation from Professor Huang Chaolong? So I will keep the question later, and then we can discuss after Professor Huang presentation. Okay. So we move to the next presentation. please show the slide for introduction of Professor Huang. Or let me introduce Professor Huang Qiaolong is an emeritus professor in Taiwan Tech. So he has a background education from the University of Illinois, USA, and he has a very excellent experience in his expertise. And we are very honored today to have him to share his experience with us. And the audience can later asking about related topic experience to him. And I believe that he very welcome to discuss based on his expertise. So without further ado, I give the time to Professor Huang. Please, your time for presentation.
Okay,
Thank you.
Chair. And good morning, everybody. It's my great pleasure to share, although I retired, but I'm so great to share the past experience of my work on fry ash and button ash. I hope that can help for this workshop, okay? Can I see the slides? Okay, the topic of this one is the utilization of fry ash and button ash for concrete product in Taiwan. And since the content actually, first, I'm talking about the birth of fry ash and button ash, the DNA of fry ash and button ash. Harmony of yin yang, that's a Chinese yin yang, okay, to stimulate the bonding fuse. And kaleidoscopic building application that you use in Taiwan, many structure. And application of road work for energy saving and carbon reduction. And I was talking about ESG function of fry ash and button ash. And also talking about feature application of fry ash and button ash, talking about zero carbon emission application. And finally, is a conclusion and documentation. Can I have a next, please? Oh, okay. Okay, as long as heat power plants use a coal production, they will have fresh production. So in the during power plant doing, okay, the coal burned boiler and the heavier one to the ash pump in Taiwan, okay, and for the lighter one flew with the heat flow. So EP electro precipitation to catch the fish light part we call fry ash or pop rice coal ash, and that to in Taiwan actually put in the ash bin, so that it delivery, direct delivery as a utilization, and those dust clean towels and fuel, okay, gypsum, and they will produce gypsum that you already use very well in Taiwan. So as long as coal heat power plant, they will have ash, and so that is the birth anyway. In Indonesia, I know that there's a lot of power plant use coal heating power plant, so that's we have a lot of ash. Next. Okay, I went. Okay, next. Okay, the DNA, actually look at the DNA is very important and very useful because the DNA of a calcium clay, actually the fry ash or button ash is a calcium clay. So, but this ash actually is impurity in coal. So that's material, iron sulfide and clay and quartz. And so this one under high temperature become very active. So no wonder in the world, it's been used widely as a porcelain material. It's kind of a supplementary cementation material. By looking at this one, you see the replacement, but it's actually is not only to replace cement. It can be as like a geopolymer, that will be very useful material. Okay, so that's usually the DNA of that one is a porcelain that being used long time ago, more than 2,000 years ago. Right, next, yeah. But looking at the shape, physical shape, you will see that fry ash just like a bead, different size. Actually, this different size is a gradation. So that's very important. Why fry ash, this shape can aid the workability of concrete, because the concrete is not only produce a concrete, but we need the workability for the construction people. So this shape actually very good for workability because it's like a ball bearing, can make concrete easy construct. So you can reduce water as long as reduce some superoxide for using making high flow concrete. Okay, next. Next, please. Okay. So there's also some burn because if we not grind the core too very fine, so there are some monoxic particle that will become an unburned carbon in fly ash. This unburned carbon actually can improve workability. So normally for the fly ash, we use a grind method to grind the particle and release the small particle out. So that's this small particle is very active, just like silica film. Next. So you look at the size is a 10 micron here. The size can be 30 micron down to 1 or 2 micron. Even those some particles are very, very small. So the fly ash, actually, the small particle can be used as a fire resistant material. So in Taiwan, actually, it's been used for some of this one can use for high insulation materials. And those particles in the big spherical ball, actually they contain a lot different size of fly ash particle. And this one, after you grind it, actually can release a lot of very useful fly ash particle. So that's what aided and then reduce more cement as the required. Next. By looking at the chemical composition of fly ash, compared with cement, Portland cement, actually class F fly ash contain less CaO, or calcium oxide, and class C fly ash contain large CaO. So this class CF is more reactive, but they were a little bit harmful to the durability. As compared with cement, it's about 62% of calcium oxide. So that's a highly alkaline material. And the fly ash actually is highly acidic material. Okay, so that can be reduced or fuel the concrete. But in Taiwan, we use a different method I will mention later. Okay, next, please. So looking at the tertiary diagram, SiO2, Al2O3, and the CaO, you will see that the relationship of class F fly ash, class C fly ash, slag in Indonesia, also a lot of blast furnace slag. That's also very useful. And cement here, and silica film here. Silica film here, usually for those very, very ultra high strength concrete, we usually need silica film. But if you use a class F fly ash, also you can have the similar result. And look at the appearance of this one. Silica film is very small, 1/100th of the cement particle. And look at the microscope by SEM and TEM. The SEM, silica film here, fly ash here, and the slag here. Next, please. And look at the X-ray pattern. the class F C fry actually, they have a diffusion band in this about 30 to 34. And class F fry is a diffusion band about 21 to 25. And majorly composition is for class F fry because contain large amount of SiO2 and Al2O3. So it's moonlight and some quartz. Next, please. So looking at the particle size, fry actually small particle. So they have very good gradation. By looking at this one, they can be used to replace cement or replace some sand also. And look at the bottom edge, the particle size is large. And this one can replace part of sand. Next, please. So how many of yin yang? And so that this one is the fry as a porcelain material should be stimulated by alkali, by external alkali or sodium silicate or some other material to stimulate the reaction, so that this kind of ash can be very useful. Next, please. So why this material are useful and is durable? Because looking on the colossal or pyramid and colossal actually they contain a lot of volcanic ash with lime. They can build the colossal in long periods, more than 2,300 years before. And nowadays, fry ash just like volcanic ash. If we stimulate by alkaline material, they can produce very long, durable material. So the antique method, we use the antique method to do this way. And the fry ash also can be used for like pyramid. They use a geopolymer. So we use the fry ash bottom ash by adding sodium silicate, sodium hydroxide, then can stimulate reaction, just like a Great Wall. It's more than 1,000 years. And they use lime, rice ash, and lime pudding, and then can make the concrete long-lasting. So we cannot say, okay, we can produce concrete durable. But if you don't use a recipe, you don't use the DNA of the concrete on the long period of pyramid, you cannot produce durable concrete, because some modern concrete only age about 50 years, then it's a problem. Okay, next, please. So in Taiwan, in order to make this concrete fry ash very useful, so we use a fry ash not by replacement. No, we don't replace cement because cement is cement. But what we are doing is fill the pore of sand. Because of the particle size, we can fill the small words. And by looking at the physical particle size distribution, we know that this material actually have a gradation. So you put into the wall, they can fill the wall, so they can stop any penetration of water. And that is from physical pore filling effect. By looking at chemical on the left-hand side, chemical effect, because fry ash or button ash by adding calcium hydroxide, sodium hydroxide, and the concrete cement, calcium hydroxide, for adding some water to add the reaction, so they can form a lot of gel and crystal. So that's the reason concrete can be lasting longer, because the reaction. So what we are doing, next please. What we are doing in Taiwan, I developed the system. I think there are many Indonesian, my student or veteran student, I instruct them how to do this one. We use a filling method, backfill or forward filling. So we decide the property of the material, and we measure the maximum unit density So we put a fly ash into sand and to measure the heavier, the dense one, so they can physically dense. So the system become very strong. Then we find that this void, and then we design what kind of property we want. You want a durable concrete, you want the anti-corrosion concrete, or you want the ultra-high concrete. We design strengths. So then we use SP to aid workability. So make the concrete flow without segregation. So we have a very good durable concrete. So you're there on the top, right top, you will see SASCON. Actually, what I'm doing in year 2012 to year 2020, I engaged in a European Community project doing this one. And also this method can be used for alkali active concrete. So we use a geopolymer method. Next, please. So concrete become user-friendly without fly ash. If only use a cement, it's become very stiff. And the superposizer will lose its mighty power in 60 or 90 minutes. But with the fly ash, the concrete can last 2 hours to 3 hours, still flowing. So conventional concrete is very stiff. And then we can design the concrete slump from 0 to 270 millimeter slump, just as what we design. So you can design the desired flowing concrete with fly ash or butternut. Next, please. Well, I say kaleidoscope because the fly ash or butternut can be used many ways. You can imagine how this material, because when you imagine that in ancient period, in Egypt, in Rome period, those buildings, they use of volcanic ash. This ash is similar. So that can make any kind, as long as you can think, you can do it. So the following, next one, please, is the project I did I think I did from 1983 to 2020, okay? So the real practice use of core ash in Taiwan since 1983, the skyscraper. This is the first project. I immerse the cement with fly ash because the people are worried about use fly ash, the strength will be low. So I try to prove and give them evidence so that engage in this project. The project is 56 MPa concrete for 85 strong. It's a high strength, high performance concrete. In year 1994. So in Taipei 101, year 2000, the strength is 7 MPa. So that if you visit Taipei, you will see the high-rise building, the tallest building in Taipei City. Okay, that is Taipei 101. And marine corrosion resistant structure, that is anti-corrosion. Fly ash is very unique and very magic material. Can consume calcium hydroxide from cement. That is a way cause corrosion because the water, they contain some sulfate. They will cause, and the cement, they will generate engine gas. So that will expand and cause corrosion. But what I'm doing is use the similar method from Kaohsiung 85 story to use that concrete only 35 for marine concrete. So Pindong Museum of Marine Biology and Aquarium. So I designed this one from pile, from building and to the roof, all use this kind of concrete and very successful. And then we also have some projects in vehicle testing center near Zhanghua in Taichung, mid Taiwan. So use a certified, and that also very successful. And the number 4 nuclear power plant, they also use a large of fry, because a lot of my students in Taiwan power plant, they use a mixed design of this one. And the porcelain concrete sewage pipe, I designed in about year 2000, and that is 35 MPa. And also Taiwan power plant middle dike. So that is also very successful. We use a fly ash, button ash to do to make a road, paver road, so that it's payment from the I think sea structure, water structure, and anti-seismic structure, high performance concrete. So highway bridge from 35 to 56 MPa, high toughness concrete. So in Taiwan steel, China steel, all the railway sleeper I designed for them is 120 MPa. That is a very high strength, 17,000 PSI. And I also designed for high integrity container for nuclear waste, that from 70 to 100 MPa. And also designed for military anti-bombing structure is 120 MPa. And then some high quality structure, I use fly ash and button ash as self-compacting concrete, Wei Center for Art Culture in Kaohsiung, and the Langgang Transportation Station. So that is a major project, but some other project I also did for the construction site. Okay, next please. So that is an example of what we are doing, and I also show some recipe, but this recipe already old. Now for the cement 387 kg per cubic meter, I can produce 17,000 PSI concrete now, because I can save about 3/4 of energy CO2 emission. So that the result I show here, that is from 1983 to 1994. Next, please. And Museum of Aquarium, okay, marine and biology aquarium, okay. So that is use 290 kilograms of cement. So that normally this kind of cement, they need more than 300 for 5,000 PSI concrete, need 500 kilograms cement. So you can see that this concrete only use less than 50% of cement. Not only we use to replace cement, but we fuel the void of sand, so they can contribute major strength. So you look at from the roof in this middle of the right-hand side, you will see that the roof also use this kind of concrete. Okay, so in this concrete, we specify the chloride penetration less than 1,000 coulomb. That is very important for the durable concrete. Next, please. For type of 1-1, you will see here, look like fly ash is 0, but actually at the end product, we use a lot of fly ash and some silica film. Silicon fly ash, actually the particle size is different, but it can be used. So that in year 1999 to 2000. Next, please. And Langgang, so that also 4,000 PSI, concrete and 5,000 PSI. Next, please. And Wei is 4,000 to 5,000 PSI concrete. So that this building get the golden award from the government. Next, please. And for the high integrity container for nuclear waste, you will see that we made this concrete. Its high strength is a 17,000 PSI strength. Use water about 120. It's very, very small amount of water because we try to reduce shrinkage. And we add a large amount of steel fiber So the concrete look outside. So they put the waste into the container and cover with it. Then we can put that for more than 300 years. Next, please. Well, the carbon core ash application for low work for energy saving and carbon reduction is very important, especially I think in the future in Indonesia. You can build the city, intercity countryside, use all this material. And that could be quite useful. And that we already promote this technology in mainland China. Next, please. And this one is in Taichung, in Changhua, actually, for the ash pond. So we use a load, use this kind of button edge fly ash. And that we use a control low strength material. And they save a lot of money, a lot of money. Next, please. So this high flowing fly ash and button ash control low strength material. In Taiwan now, we have a label with a green material because that's save at least 50 to 60% of cement. So the concrete like this one, flowing like this one, can fill the sewage pipe. And this is a very common use in Taiwan. Next, please. So in Taiwan Power, we also, in year 2010, use for the payment, for the load around the power plant. So use a CLCM. And we check the quality. Next, please. 2 days later, we use a roller to roll the road. And then the CSM, there's no crack anyway. So that's the surface is good. So for the titration, we use a load. It's a gravel aggregate put in there, and the load actually will crack or some problem because but use a CSM, you modify the land, the ground. So this CSM just looks like the soil, but it's better for soil. Next, please. And 4 days later, we'll pour second or third layer and traveling with the manual leveling, or you can use a automatic machine to flow in the surface. So that looks very well. And the result now, till now, year 2022, still very good shape. Next, please. Well, ESG function of fly ash and button ash. I think for the circular economy, but very important to meet sustainable development goal from the United Nations. So we try to have a sustainable city in the 11, and we are responsible consumption and production travel, and also the economic growth, the number 8, economy, industry innovation, number 9. So this one is we try to use a button ash and fly ash that can be useful, and that will have good for the number 3, good health and well-being. Next, please. If we don't try to reduce CO2 emission, the greenhouse effect causes disaster. Another typhoon, monsoon, or fire on the forest, and the forest drought all the world. I think now they have a big problem. So we try to save energy, save the earth. We should use a lot of this button ash and fly ash to try to reduce cement usage. Next one. Next one, please. Next, please. Okay. Well, we know that 1 ton of cement will emit 0.85 tons of CO2, consume a lot of the electricity and fuel. Okay. Next, please. So this one, we try to use less cement. We can become the environment-friendly material. So the fresh bonded edge provide a chance for us to use it. Next, please. So how to do and how to make the concrete durable without fresh and bottom edge? Actually, the building cannot last longer, because I have a lot of experience doing slag. Only use slag, you have a problem. Okay, only use fresh and also a problem. So I usually combine these two together, and so these fresh it become a kind of K shell, KT kilo shell from our body. So this lime and pozzolan that can make the concrete sustainable. Next, please. So we pursue the high quality, the material is very important. So the fresh bottom edge material and process is important. So we not only need very good design of the recipe, but we also have a very good process, like a chef, to process this and then make concrete healthy and long-life. Next, please. And durable and sustainable. If the cement paste is the lot more, the durability will reduce. So we try to use a fresh and bottom edge to reduce the cement paste and increase the durability from the fresh stage to hardened stage. Next, please. Concrete with large amount of core edge. Then in Taiwan, we already deemed as green concrete with 50% less cement based on the same strength, and control low strength material with minimum cement for most back feeding job and low base project. Next, please. So this show you some data for some remarkable project. You see how many CO2 reduction in the blue circle. You will see that actually there's a lot of reduction of CO2. So for the circular economy and for our future, this is very important. Next, please. So future application of core edge and bottom edge, zero carbon emission. Its pavement, asphalt concrete low base subgrade, brick insulation brick, ordinary sinter brick and slam tile, lightweight foam brick, lightweight aggregate agriculture, and also geopolymer. Next, please. Well, for the European community, the project we did, we use all kind of waste. Use geopolymer as a binder, use bottom edge or waste material as aggregate. So that can be an example for future application in Indonesia. We use a rubber tire, we use a gel foam, we use a plastic material, then can be used as an aggregate. So that can be very, very full. Okay, next, please. So we use a geopolymer to produce the SUSCON, sustainable concrete binder and nature. Okay, next, please. And this concrete actually flooring. Okay, so you will see that we use all the waste material. So we try to use all waste, totally waste. So during the design and testing of a SUSCON concrete. Next, please. So that's the plan we are doing. The European company, they use the company produce help industry. So the project we finish, just then they deliver to industry. Next, please. So we do some test panel. Use you will see this one geopolymer. You look at shape. Okay, so we can produce a brick and all other material. Next, please. So that's a brick. Okay, next. Conclusion and remark. Okay, so in the future, we need a big data, a lot of data. So in the future, we can design concrete, use artificial intelligence, and use IoT. So in response of the 4G era, build all this operation information. So we design and we can test, so we can establish complete GIS information system, establish a digitalization of flying bottom edge data bank, and we can calculate carbon tax, okay, in the future. Next, please. So we will have a sustainable Earth, energy saving, and carbon reduction, just as Steve Jobs and Einstein use our imagination, create more application case for the future. Okay, thank you for your attention. Next, please. And if there are any question, I can answer the question. Thank you very much for your attention. Thank you.
Thank you, Professor Huang. It's a very interesting presentation, and you shared a lot of experience. It's very valuable for us. And it's really great honor here. We have Professor Huang for discussion. So I open the session for question. But first, I will read the question. Maybe this one is for Bu Chanwarti from Mr. Tanaka. Fly ash contain the toxic heavy metal. How can we think about an effort to ecosystem by being leached out from this material? So that's the question that I read from chat in the Zoom. So please, maybe Bu January can address the question.
Yes, thank you, Bu Kelly. I agree that byproduct may contains a lot of minor minerals like heavy metals or some, constituents that may be leak out to the environment. But here, by doing the solidifications, for example, we mix fly ash or biomass with cement, and also mixing the coal ash with the alkali to make it solidify. So during my experience in Indonesia or in Japan also, I've never seen any leaching of very dangerous material, for example, like chrome, or we're also worried about the maybe zinc or TB or even boron. Boron can be found abundantly in the fly ash, and it is easily released to the water. For example, if we have fly ash and the piling of the fly ash is not properly placed in the yard or in a power plant, we worried that the boron can leak out and penetrate to the underground water. But here in Indonesia, we have a very strict regulations. In the regulations, we control also the constituent of leaching of the fly ash to the environment. So long time ago, before last year, we suffer from these regulations because it is too much strict as ever. So because of that, fly ash and biomass was considered as as a toxic material, hazardous material, and because of that, nobody wants to use that. Everybody's scared about the regulations, so the utilizations of the fly ash becomes very difficult because of the regulations. But fortunately, last year in February, we changed. I mean, the government changed the regulations, and fly ash, also biomass, are delisted from the regulations, from being hazardous material to byproduct material. And also we conducted some experiments. We call it LD15, LD50, and we use rat, mice, and we feed fly ash and bata mass to the mice, and there is no problem. So it means that I cannot say that this material is safe to as we can touch the sand, or we can touch the soil, but also we have to control the safety, because this material is very fine, and like a dust, we have to wear a proper protection during using the flies, and we recon the flies just as the same as we play with cement. So as a cement replacement, we consider fly ash as a binder. So it is safe. And we check also the constituent, the leaching of the fly ash by using, we call it TCLP. It is a kind of a test for toxic leaching, and all of the result below the maximum in the standard. So I think that it is safe to use the fly ash in Indonesia, at least Indonesian fly ash. But I don't know about the other fly ash in other country. Maybe I found in some journals that fly ash in the South Africa contain a lot of boron. And boron is not a toxic material, but it can decrease the harvest of some plantations, and it can also bother some the growth of the paddies, the rice, if we use it too much. But indeed, in Korea and also in China and some part of India, they use fly ash and bottom ash as a fertilizer or soil stabilization. And I think for small amount is okay, but a large amount maybe is not recommendable.
Yes.
Thank you.
Thank you, Bu Januarti. I think Jenny already raised hand. Before I go for the question in the chat, I give the time for Jenny to deliver the question.
Okay, thank you, Professor Felicia. Actually, I would like to ask Professor Huang response about the case in Indonesia about the protection of coastline that Bu Januarti has shown us. What do you think about that, Professor? Is there any technology transfer from Taiwan to Indonesia that we can do, Professor? Yeah.
Okay.
Yes.
It's a question.
Yes, I think the question is about based on your experience, Professor Huang. Maybe you can sharing how to mitigate or to give a protection in the video that Bu Januarti already showed you in the first presentation.
Okay, I think the technical transport actually in Taiwan transport to most of the Taiwanese, and once things. So if you want to try to use a button edge and flash successfully, actually they have some key, okay, to do this one. So in order to produce very stable and high quality flash button edge concrete, you need 5M. 1M is a man. So you need a very good idea. I think in Indonesia, a lot of their students from NTUST and all over the world, they know how to use a flash. So man is very important. Material, I think material is important. So I think that Mr. Tanaka-san asked about the some toxic material. Actually, in Taiwan, the top material we already checked. No, those kind of heavy metal. So it's we don't worry about it, because in Taiwan a lot of people worry about the material. So material is very important. So button edge, fly edge, we check it. And also usually we will use some slack. So some Christian ask me, Walmart asked me this one is this material actually fly edge we used to use a DMD method. So in the PowerPoint, okay, in the slide, you will see that we use a fly edge to fill the void of an aggregate. So then aggregate, so material is very important, recipe is very important. And the slag, we usually not fill the void of the sand. Okay, we've replaced 20 to 50% of cement. So they can further reduce a lot of cement. Okay, so that is a secret of this one. Okay, main material, machine. In order to produce very good concrete, the machine is very important because you use a small amount of cement. You might use a small amount of fly ash or other extra material inside that. How you can blend it very well. So I usually design a machine, and that is some pattern, okay? We use a machine to blend it, and then the concrete will be homogeneous. So for those cementitious material, well blended, homogeneous dispute is very important. And in that case, also you can put the STIC fiber, the PP fiber, to increase the durability. So there's so many different methods to do. So the machine is very important. The money, okay, you need to invest, have a good machine. Without a good machine, you can produce very good concrete. Okay, so in the machine I design, actually 80 seconds, you can produce one batch, continue pouring, okay, without some terminating, no, you just continue. And then mass storage. So I mentioned mass storage is another way to produce very good concrete. Important is you put the water just like ASTM 109 or ASTM 190, the blended mortar. So the method are quite the same because it's according the hydration of cement. So if you do this way, so 5M, then you can produce very good concrete. And sure, if in about 10 years ago, I tried to introduce this one in Indonesia, but not successfully because a lot of trouble, okay? But I think it's a time because NTSD and Indonesia try to cooperate together and then can use a very, I think the very familiar method to introduce Indonesia. And then I can help to do this one. Yeah, because if you have all this one, you can produce the concrete actually every day. It's just like a 7-Eleven or McDonald's, still good. Not only very good enough, but it's good. Okay.
Okay, thank you, Professor Huang. Yes, you already answered the question for Jenny and also for Puwarma. Yeah, another question in Indonesian, I will translate it into English. But I think I would like to add your 5M becomes 6M. We need the master, Professor Huang, and you are the master to run it. So it should be 6M, not only 5M. Okay, for the next question is fly ash and bottom ash is including in the hazardous waste in Taiwan? Is it hazardous waste in Taiwan? And regarding to the utilization to fly ash and bottom ash in Indonesia, because before, as Bu Januari said, just last year, government released the regulation that fly ash and bottom ash is not hazardous waste anymore. So as just you said, Professor Huang, that it is the time to start it in Indonesia. But there is a question regarding to Taiwan. Is it hazardous waste, and how is the change? Maybe you can share to us. I think before it's hazardous waste, right? And then how it is changed.
Yes. Well, it's a hurt on me. Since 1983, I come back to Taiwan from UIUC, Illinois University. I try to convince people to use a flash because it's a kind of waste. You should use a waste to pay money, okay? You pay money to the people to treat it. But I spend 8 to 9 hours, 8 to 9 years, and do a lot of research work from 1983 to 1990. Okay, so I try to use all this material and prove the strength is good. So I get a lot of fund, a lot of grant from industry and from Taiwan Power. They provide money and they give me a lot of flash and button edge. I do it, I check the data is good. But people say, I know it's good, but I don't use it. Because they have a trouble of that, it's a kind of a hazard material and it's a waste. But I use 9 years, I provide all the data, and then until 1993, I come back from New Mexico University, I am a visiting professor, and then I use waste material, flash and button edge, and then use a silicon superparasizer with a slag. Then I first produce the high-rise building. I use a hypermix concrete for 85 stores. So that is first example I use for concrete, make flooring, and use a lot of flash. That is first case. And until that, I give a lot of talk, at least 5 seminars to educate people, educate government sector and consultant. Let them know this material is good. Without use that, you will have a you will feel guilty if you don't use that. Until now, from 1994, flash you used. You will price flash before is a 1 kilogram of flash. You will give $1 or $2 to treat it. But now, $1 or $2, the price is quite similar with men. They're quite similar. So without flash, the concrete cannot be flow and lasting 2 hours, cannot be a high strength. Now I use about 300 kilogram. I can produce 17,000 PSI concrete. Can you believe that?
That's
so that
amazing.
Is the way I do. So I had trouble at the beginning, 8 years, but luckily I success to do that. But I retired.
But you are still the master, Professor. So we really need your experience.
No problem.
We are
no problem.
looking forward to welcome you here.
NTUSD and the bridge now is built up, so we can use a high speed to go through that.
And in the question, he or she asking, Babak Sutanto asking that, is there any regulation in Taiwan the rule to use the fly ash and bottom ash? Is it any regulation in Taiwan?
Not really, no.
Oh, not really. Okay.
No.
So
because as long as you can use it, because I also give the people talk it just like the slide I provide. Use a flash not to replace man, but you try to dense the structure.
Yes, that's really important and useful for the concrete. And I enjoy your presentation and also Bu Januarti. But because we have a very limited time for the next presentation, we really thank you for Professor Huang and Bu Januarti time. We give applause with
thank you for your
there
attention.
Is another question. Bu
Yanti asking something, Bu.
Oh, I'm sorry. Please, Bu Irianti. I'm sorry, Professor Wang. There is still another question. Please, Bu Irianti.
Yeah, okay.
Okay, thank you very much. You hear my voice clearly?
Yes, we hear clearly.
Okay. Yeah, thank you, Prof. Wang. It's a very interesting topic that utilize the bottom as and fly as. Actually, I'm Yanti and come from Lambung Mangkurat University. It's southern part of Indonesia. And in here we have a lot of ways for the bottom as and also fly as. So I think it's also collaboration for the chemical engineering, especially for the process, right? For produce the high quality of the material. So my question is that the material which you produce is applicable for the other countries, especially in here, because we have only 2 seasons in here, and in Taiwan have 4. So it's already have a qualifier for this one. So because we have maybe the bottom as and also the fly as is the different composition. Okay, that is my question. Yes. Thank you very much.
Yeah. Well, the composition is quite similar because the fly ash and bottom ash is the birth of the DNA of the birth of the fly ash bottom ash actually is a clay or quartz. So you don't worry about. In the world, actually, there are so many international conferences organized by Mohatra, Professor Mohatra. He's retired. So he tried to give the people idea. This material is very useful, especially the Professor Mehta from UC Berkeley. They use the idea, the concrete can last in 1,000 years. So you build a temple in Hawaii. So you don't worry about that. The composition is quite similar. SiO2, Al2O3, and FeO2O3 about 75 to 80. That is clay. Because you dig out the core, you have a clay, of course. So you just dare to use it, no problem. You will find this material are very unique and very useful material. Can give you a lot of recycling economy. You will do that. Okay? Is that a question?
Yes.
Answer?
Okay, thank you.
Hope you successful.
Okay, hopefully. Thank you.
Okay.
So thank you so much to Irianti for the question, and thank you for Huang and Bu Januarti once again for answering all the question and presentation. I return to Bu Warma for the next presentation. Thank you so much.
Thank you. Thank you.
Terima kasih. Terima
Bye.
kasih.
Bye.
Bye. Thank you very much, Professor Huang and Ibu Januarti and also Ibu Feli for a very interesting discussion and talk today. And for the second session, I would like to invite Ibu Dr. Jenny. Dr. Jenny, are you there? Ibu Jenny, do you have problems to say? Jenny is lose connection. Okay. Yeah, we wait for Ibu Jenny to come, but before that, I would like to invite General Manager, Mr. Amos Chang.
Yep.
Yeah. So, good morning.
Good morning.
Good morning, maybe already good afternoon here. So, yeah, and this season, Dr. Jenny will be your moderator. But before that, I will be maybe take
Hello, Bu.
okay, Jenny already in here. Yeah,
Oh,
Dr.
sorry.
Jenny, time is yours, so you can continue with the General Manager, Mr. Amos Chang. So please.
Okay, thank you, Bu. Okay. Hello, everyone. Hello, Mr. Chang. Let me introduce myself. My name is Jenny. I am the new lecturer in Widya Mandala, actually, but I'm in Taipei right now as the invited visiting scholar invited by Professor Liu. So, yes, I would like to, it's my pleasure and honor to be a moderator in the last presentation today. will be presented by Mr. Amos Chang. Okay, and he is a general manager in Chungthai Research Technology Corporation, and of course he has a lot of experience, and he's an expert in the environmental and recycling process, and he got his master degree in Institute of Natural Resource Management in National Taipei University. So without any further ado, oh yeah, by the way, Mr. Amos Chang will bring his presentation in Mandarin. I think we should use the interpretation option in the Zoom. Okay, so without any further ado, let's welcome Mr. Chang to give the presentation. Please, Mr. Chang.
好，与会各位先进大家好。接下来我跟各位介绍有关中台资源科技在废弃物资源回收上的解决方案。我会分以下2个部分来跟各位做介绍。第一个部分是有关我们中台资源科技的 ESG， 还有我们第2部分是我们中台在台湾有关资源回收方面的解决方案。中台资源科技成立在2001年，然后到目前已经进入到第22年。我们成立的宗旨就是要善用这个物质，让物质充分发挥效用，然后让民众富裕，也就是我们目前各国推动的所谓的循环经济跟永续发展。那在这样的理念里面，我们22年来，我们持续发展好，把这个废弃物摆对位置，然后尽量让废弃物能够资源化。那没办法资源化的话，我们就进一步把它能源化。那目前我们中台设置的就主要的营业范围包括的含汞的废照明灯管的回收处理，还有废印刷电路板的资源化。那我们在3年前新建的这个焚化发电厂，然后到今年3月正式营运。首先介绍一下我们这个中台资源的一厂是一个这个焚化发电，还有刚才黄老师介绍的焚化过程里面产生的飞灰跟底渣，我们也在厂里面做再利用。那我们主要服务的对象是在台湾的，像台积电的半导体，还有面板业的友达，还印刷电路板等等的行业产出的废弃物，进到我们厂里面，我们最主要是做焚化处理，然后再做热回收。那在过程里面也会做这个废弃物的这个相关的固化处理。那最主要是让废弃物无害化，然后回收它的能源还有物质。那再来是有关我们中台的2厂，那这个厂主要是处理废照明灯管，主要照明灯管里面含有汞跟荧光粉这些有害物质，需要妥善的处理。那我们这个厂主要具备的核心技术是有关蒸发浓缩，可以把这个汞进一步的蒸发，然后回收纯化，有一个很高的回收效率，然后就是进行无害化跟这个资源化。那另外我们的3厂最主要是做废印刷电路板，台湾是印刷电路板的重镇的。那整个台湾在处理过程里面的废印刷电路板里面含有玻纤树脂跟铜，那我们进一步进行的回收，在整个台湾的印刷电路板业的回收 废电路板的回收，我们占了50%的这个占有率。那主要我们是核心的技术是用干式跟湿式的破碎制程，来把铜跟玻纤树脂做分离，然后再用水来当媒介，然后进行全回收的制程。那回收铜跟那个玻纤树脂产制成这个混凝土参料，用在营建工程上面。那我们服务的客户就包括了机体电路、面板业、电路板，还有其他的相关电子产业。我们服务的客户到目前累计大概有330家以上。那我们长期跟电子业的互动，那也是电子业绿色供应链的伙伴，所以相对我们在整个品质的管理跟 ESG 这个质安卫的环安卫的管理上面，我们就是从这个进料，任何废弃物进到我们厂里面，我们会先进行采样分析，然后符合我们可以处理的项目，我们才跟客户签订合约。签订合约以后，才这个清运进厂。清运进厂过程里面，我们还是会做抽样分析然后分析完以后再称重入库。那依照我们不同的处理程序，我们再进行领料进行焚化或是固化等等的处理。那处理过程里面，我们会产制相关的再生产品，进一步的做再生产品的检测，符合品质规定再进行销售。那处理过程里面也会有衍生的废弃物，我们进行衍生废弃物的妥善的处理。那因为废弃物的种类项目很多，所以我们内部有设置大概200平6间的检测实验室，最主要针对焚化的部分进行相关散火点热值3成分等等流率含量的检测分析，了解物质的状况，然后再交给后段做相关的参配，然后再进行处理。然后固化的部分，我们包括2个部分，一个是那个飞灰有 fly ash 的有害飞灰的，我们是进行固化的处理。那固化完以后，我们会进行毒性溶出跟抗压强度的测试。那在 bottom ash 上面，我们是做资源化，做成 CSM 跟这个再生粒料，那进行相关流率含量、抗压强度的，还有这个环境相容性的这个检测，然后再进行销售。那另外还有化学洗净也有相关的检测分析。那除了物料分析以外，我们也进行环境分析，还有员工作业的相关的检测分析。那我们厂里面设置的相关的检测的仪器，包括了这个热值啦、重金属啦等等的这个设备的分析。那值得一提的就是，我们中台除了做废弃物的资源化回收处理外，我们在3个厂都有设置环境教育的场域，然后把我们整个做处理的相关的技术，还有环境保护、资源回收的理念贯彻在这个教育训练里面，然后开放给这个政府机关、学术单位、民间还有国际进行相关的交流。我们从2008年设立环境教育场域，一直到去年累计参访的人数大概接近8921人。那刚才提到我们3个厂，就是第一个就是我们3厂做废印刷电路板的回收处理。我们从2015年成立到去年7年里面，我们一共处理的台湾大概有87700多公吨的这个废印刷电路板。那从里面破碎分选出铜有25000多吨的，也就是所谓的城市采矿。因为台湾不产铜，可是我们从这个电路板业里面去把铜分离出来。那相对就是我们从这个日本的铜合金属，它做这个碳足迹的盘查里面，我们可以了解，就是原生的铜跟再生的铜跟城市采矿的铜，它的碳排放量 大概差了10倍。那我们间接可以减少二氧化碳排放量大概是11000多吨。那另外我们这个2厂最主要是做含汞灯管的回收，我们从2002年一直回收到去年，总共回收的废灯管的量大概达到45700公吨左右。那从里面回收的大概有8.2吨的这个汞，那减少这个原物料的使用，那也减少这个环境的危害。那另外在这个环境教育上面，大概参访的大概有8900多人。那以上是我们整个中台资源整个营运 ESG 的一个策略跟目前的绩效。那接下来主要跟各位介绍有关我们中台在废弃物资源化上面的一个解决方案。我们中台的整个理念就是把废弃物摆对位置，让它能够尽量的原料化、资源化，那不能原料化、资源化就进行热能的回收。那目前我们一共设置的有3个厂，那接受台湾有关电子业、半导体等等这个电子产业，还有化工业，那甚至医疗，因为现在 COVID-19 的疫情，所以相对有很多防疫旅馆这个医疗废弃物量在台湾大概增加了4倍。那我们新设的中台1厂也协助台湾政府去去化这些这个防疫医疗的这些废弃物的处理。那另外住商的照明灯管的回收，那经过我们3厂把这些废弃物处理完以后，然后会产制相关的这个贵金属或是玻璃或是电力，然后再回到这个相关的台湾的产业上面。这是我们整个中台资源营运的这个循环蝴蝶图。那细部的介绍有关我们中台1厂这个焚化发电厂。我们设置的焚化发电厂主要是处理台湾4业废弃物，也就是因为电子业在台湾设置就是这几年来这个投资设厂扩厂的很多。那我们设置这个厂主力就是要服务台湾的电子业，因为电子业本身产出的废弃物种类形式非常多元，有这个混合的溶剂类的、酸碱的，然后另外还有很多固形的固体的废弃物。那我们是设置有固体的焚化线跟液体的焚化线。那固体的焚化制程，我们基本上考虑到，因为4业废弃物里面除了固态里面，它还有粘稠、胶状的。那这些在焚化过程里面是比较容易交结，这个会在炉体里面形成结构，然后损害这个运行焚化的运行。所以我们在固体的焚化设置上面，我们是用短旋窑，也就是直径5米、长度8米的这个短旋窑，然后再连接后面的机械炉床，2段式的焚化来处理这个台湾4业废弃物多元的这个废弃物的问题。那因为焚化的过程里面一般呢，就是废弃物的这个含氯硫的含量还有热值是不一，所以我们经过这个前段的调配以后，再进到我们的这个入料口，然后再进到我们的短旋窑跟机械炉床去做焚化。那焚化过程里面，就是我们一般呢这个废弃物的焚化，就是100吨的废弃物进来焚烧，大概有这个产生15%，也就是15吨的这个底渣 bottom ash。那另外就是有5%的飞灰，飞灰来自于锅炉灰跟这个 backhouse 的反应灰。这刚才黄教授已经都提到了那因为整个焚化过程里面，刚才提到就是5%的飞灰，15%的底渣，那意思就是说还有20%的这个固体物都被烧成气态。那相对气态里面的污染物的成分特性就很多。那我们主要的重点就是 除了安全稳定的燃烧，把这些废弃物无害化以外，很重要的就是要很好的这个空污防治系统。我们设置的就是第一段这个是2次燃烧室，最主要焚化过程里面有一些非化性的有机气体，经过我们2次燃烧室，让温度提升到1000度，停留时间2秒，把这些 VOC 有害气体把它焚化破坏。破坏完以后接下来就是要除 NOx。NOx 是很重要的去除的重点。那我们是先因为经过这个入口以后，这里温度大概在950到1050度左右。那我们在这里喷氨水，就是第一段的 SNC 啊。好，那去除完以后，这个烟气经过锅炉来回收它的热能，然后形成这个水蒸气，然后再推动涡轮机发电。那电力我们有2/3自用，然后1/3卖给这个电力公司。那这里的过程里面，我们就是也让它实现热能回收发电的这个效果。那经过这个锅炉回收热能以后，这个烟气再进到第2道的 SC 选择性触媒，在第2道的把这个 NOx 把它还原成氮气跟水。那去除 NOx 完以后，再进行这个困取半干式洗涤塔，最主要是用这个液碱，让这个来除这个 HCl 跟 SOx 这种酸气。那主要是也有降温的效果。那降温完以后，再进行 backhouse。backhouse 我们有特别就是在管线里面，我们喷注了活性炭跟这个小苏打，在这个喷完以后，这些活性炭跟小苏打就会附着在这个 backhouse 的这个滤布上面。那最主要是要去除酸气，还有重金属，还有带凹芯。那去除完以后，我们再接续在第2道用 wet scrubber 再除酸。那除酸完以后，我们再热回收交换，然后把温度提升到120度左右，让整个烟囱排放的气体不会有白烟现象，就是全部都是洁净化。那也设了24小时连续监测系统，来管控我们这个排放烟气的这个情况，稳定符合这个排放标准。那这是我们整个设置的一个流程。那目前我们支援就是台湾政府的这个疫情的这个相关的医疗废弃物的处理以外，另外就是像台积电有一些保密性的这个报废的晶片，也都是经过我们的处理。那另外一体炉的部分刚才提过，最主要就是我们处理这个没办法回收的废溶剂，因为它是混合的废溶剂，那我们是用喷注式的焚化炉来做焚化，然后后段的这个锅炉啦、空污系统是一样的。那这是我们中台1厂的设置。目前我们固体炉一天的处理量可以达到100吨，液体炉的话一天可以处理80吨。那目前我们整个资源化的情况，最主要就是这个锅炉灰跟这个反应灰这2个飞灰目前我们还是采用传统的，就是加水泥那个螯合剂，让它成固化体，无害化以后再做最终的掩埋。那目前我们也朝这个整个全循环的路线走我们现在也开始着手像刚才黄教授提到的相关资源化的方向以外，我们也考虑到用飞灰水洗无害化，还有飞灰熔融无害化的相关的技术的研讨。那另外就是有关烟囱的二氧化碳的排放，我们也考虑到就是做二氧化碳的碳捕捉再利用 CCUS 的相关的技术的探讨。那再来介绍 到我们中台二厂，这个是我们成立20年哈，在台湾有关这个废灯管的回收上面，我们目前哈在台湾占比大概是80%。那我们从相关的清运回收业回收回来的灯管，我们会进行分类，因为灯管有直管啊、环管各式类型的，我们需要做相关的分类，然后再进行破碎啊，因为灯管里面含有汞的成分。所以我们制程最主要就是全部在负压的情况下，用热脱负的处理模式，就是温度让它控制在这个600度，让汞能够蒸发，蒸发冷凝下来以后，我们再做收集。那冷凝下来的时候都是比较属于粗汞，那我们再进行精炼，让它纯度可以达到4个9的纯度。然后可以再利用，那这是我们整个废灯管的回收处理流程。那因为废灯管含汞的荧光灯管慢慢被 LED 取代掉，所以我们相关的转型我们也新设的这个热裂解制程。最主要考虑到就是因为我们发觉日本在有关废电子物品的回收技术上面都非常的先进。而且他们也考虑到各国去富集有关这个贵金属，那所以台湾很多的这个电子废料含有复合金属的，基本上都是运到日本或是中国去做处理。那我们在台湾就新设的这个焚化制程，最主要是把含贵金属的复合材料进一步的把它碳化，让这个贵金属能够裸露出来，然后再进一步做金属的回收，然后让这个贵金属能够留在台湾。那目前我们做热裂解也跟这个相关台湾的贵金属的厂商做合作模式，拿来处理这一块的这个项目。那另外就是有关这个废印刷电路板，废印刷电路板我们主要是因为一般印刷电路板一块的尺寸大概都是50公分见方，那我们经过这个干式破碎，把它破碎到大概2 mm 以下，然后再湿式破碎，然后我们是运用水摇床的方式，用重力分选，把铜跟玻纤树脂做妥善的分离。铜的话可以变成铜粉，然后玻纤树脂我们进一步改质，让它变成混凝土参料。供这个工程土木可以使用，那达到水的话，就是在整个运输上面都可以全循环。这是我们的整个运作的模式。那最后提到就是刚才是我们中台资源主要是做回收那我们也跟台湾很大的这个废弃物的掩埋固化掩埋场可林卫做策略联盟。我们除了这个处理端以外，我们延伸到前面有做这个废弃物媒合的平台，也就是把台湾相关产业产生的废弃物的厂商，还有台湾清运业者、回收业者都纳到这个平台里面来，然后在有关废弃物的需求清运处理上面做一个媒合的机制。那媒合过程里面，我们有自己的清运的车队，到相关的产研机构做废弃物的清运回收，然后回收的话就进到我们中台资源做相关的回收，然后要焚化处理的话到焚化处理厂，焚化完以后相关衍生的废弃物需要固化掩埋，形成一个一条龙上中下游的资源循环全方位的一个解决的一个模式的流程。那我大概快速的介绍到有关我们中台资源的整个处理解决方案。那也非常欢迎各位，假如说有机会到台湾来的话，也欢迎大家可以到我们工厂实地来参访指导。以上快速的介绍，谢谢各位。
Okay, thank you very much, Mr. Chang. So yeah, we go to the Q&A session, okay? And I found many questions already about Mr. Chang's presentation. So first is from Mr. Sustanto Kusumo. Okay, how to separate the electronic waste in Taiwan, and is there any regulation that that obligate the that obligate the citizen for the separation? Yes, please, Mr. Chang.
I think Michael should interpret to Chinese, maybe.
Or perhaps I can do the translation.
Oh, please, Professor Liu. Thank you.
谢谢张总经理哈。这位印尼的朋友想问的是说，台湾有什么样的法规呢？要求业界或者是我们的市民呢，一定要做这些废弃物的分类跟回收。
这个是很好的问题哈。因为台湾的废弃物的分类回收，除了我们传统的就是像废纸啦、塑胶啦、纸类，这一般在整个那个民生上面都会做妥善的回收，因为它是有价的。那另外考虑到就是环境没办法负荷的，例如就是它含有危害物质，还是对环境长期不易腐化的，然后没有回收效益的。那这个政府就要来做统筹管理，例如我刚才提到的这个含汞的废灯管，因为它本身就是含有有害物质，那变成台湾就会成立一个所谓的应回收制度，让延伸生产者责任从这个产制灯管或是代理灯管的这些厂商要收回收清除处理基金，那我们这个厂主要就是协助处理完以后，回收清除处理基金依照我们处理的数量，然后来做分配，然后前段分给我们处理，也分给前段清运回收的业界。
Jenny, should I do the translation or it will be translated into Bahasa?
I am not sure.
It's already translated to Bahasa. So maybe Jenny just translate in English and then Professor Liu translated to Chinese, and then the answer from Mr. Chang will be translated to Indonesian directly.
Oh, okay. Professor Feli, so I can just continue to another question, right?
Yes, please.
Okay. Yes. Thank you for the answer, Mr. Chang. So another question is from Yamtana from Yogyakarta. So the question is how to treat the hazardous waste of and the electronic waste and another waste as completely. But I think the answer has been shown by Mr. Chang in slide 17, if I'm not mistaken. So yeah, maybe Mr. Chang can explain it more, please, Mr. Chang.
对，张总经理，这位印尼他们在 Gajah Mada 这边的教授呢，他想了解的是说，我们在电子废弃物呢，怎么样子做有效的分离啊？虽然说主持人说，其实你的投影片已经讲得很清楚，但是也许你可以在电子废弃物的回收呢，再稍微再琢磨一下。谢谢你。
好，有关电子废弃物我们大概可以分成两种一种就是因为台湾电子产业很多，所以电子就是像做电路板的。印刷电路板业，它就会有废板边料，那这一类的就是它含有铜、玻纤、树脂等等。那另外一类就是电子产品汰换出来的，例如我们的家电、资讯产品。那这两类在台湾它是这样，就是生产制造业衍生的废弃物，就由事业来做相关的回收。那回收包括就是 台湾有2个部分了，一个就是做粉碎破碎完以后，再由后面有关精炼厂它回收这个贵金属，例如金银八铂这一类的系统。那另外一类就是应回收，就是这个废家电还有这个废资讯物品，它经过拆解破碎完以后，会分离出一些电路板。那电路板里面有一些电子零组件，那在台湾在处理这一块技术还没发展的很完整，所以基本上都是由日本来接收这一块做后端的处理。那这也是台湾目前所有的产业在做整合，例如我刚才介绍的我们的热裂解，我们就跟金益鼎贵金属合作，那我们在台湾就可以把这一块把它处理掉，不需要日本就是运到日本去做处理。我们希望就是台湾慢慢的去做这一方面资源化的连接，让我们的资源化的这个高质化能够往前迈进。
Okay, I see Bu Januarti raise the hand. So yes, please, Bu Januarti.
Yeah, thank you. Yeah, it's very interesting to see your presentations. And I just remember that maybe 6 or 7 years ago, I visited Taihei Cement in Japan. As you know that they are doing almost the same things. They get the waste from the municipal city, from the Tokyo government, and also they separate some materials like you have done, and they found out that of course some materials is useful to make a cement, and they have come up with the idea to make a cement, and they produce eco cement. So this is the first cement in the world made from the waste municipal city. And my question is, are you going to do the same things? Maybe because it's quite interesting, and talking about money, it's a quite big money to make a cement industry from the waste. Thank you very much.
Maybe I can answer the question. I don't think Zhongtai is involved in making cement.
I see.
It's more like upstream, treating and try to extract the usable, valuable resources from waste, particularly from the high value added e-waste. Let me do the translation. 张总经理，这位印尼 ITS 顶尖大学的教授呢，他要问的问题是说，他7、8年前在日本参观过，他也是在日本念博士的。他说日本有一些这些焚化炉的处理呢，就是除了处理之外呢，也会做成比较绿色的或者是生态的水泥他不知道说他想了解说中台公司呢是不是有这方面的打算，然后呢比较比如说利润或者是附加的价值这方面呢想了解一下公司的这个掌握是什么样子，麻烦你，谢谢。
好，这是一个很好的问题刚才提到就是我们整个焚化过程里面最主要就是这个焚化完以后的这个底渣，那另外就是锅炉灰跟这个反应灰。那针对底渣，底渣本身是无害化的物质，那在我们厂里面我们会经过破碎，让它破碎到粒径大概在19 mm 以下，然后再经过涡电流，磁悬涡电流把铁跟铝这些物质把它去除掉，然后再进一步变成这个底渣。那底渣过程里面我们做出来有2种产品，一种是 CSM， 那另外一种就是再生粒料。那做的过程里面我们因为过程里面要加水泥，水泥就是成本，那做出来的 CSM 跟再生粒料，这个对外到这个营建工程变成我们要跟这个混凝土厂做合作，那基本上我们的量很少， 跟他们占比差太大了，他可以不用我们，所以目前我们变成就是没有主导权，所以相对要靠他们。靠他们的话，他就是会压低价格，甚至我们要补贴他清运费用。所以说实在的，就是我们这一块几乎没办法赚钱。目前是这个情况。
Hello, Professor. Sorry that if it's possible, Professor Liu can translate a little bit in English because some of the terminology maybe we don't understand because mostly using this like chemical and construction part. Very sorry, Professor.
No problem.
Yeah.
GM Zhang says that this is a very interesting question. Actually, they do reuse the butter mesh in the incinerator to make eco cement. However, the quantity is so little that they do the collaboration with Japanese company. However, the market is so limited and the value is also very meager. So it's not profit making.
Yes, I see. Thank you very much, Professor Liu. Yeah, Mr. Chang, thank you very much.
Thank you.
I really want to visit. I really want to visit. Yeah, I've never been to Taiwan. I mean, like just a transit during my flight from Indonesia to Japan. So yeah, I've never visited properly Taiwan to enjoy Taipei and also the university. Maybe next time I can visit.
Yeah, definitely we can visit Zhongtai Resource Corporation because the company is so close to Taoyuan International Airport. I think it's like you're talking about 10 minutes by car. And when we visited Zhongtai, was hosted by GM Zhang. Actually, everyone, all professors were very much impressed. Okay, yeah. It's a more like a model company when it comes to circular economy. Okay, yeah, you definitely if Genuati will be invited as soon as possible.
Yes. Yes, thank you very much.
Yeah.
Thank you. Okay, is there any more time, Wawa, so that we can continue another question?
Yeah, we still have some question because the time is still ongoing, Jenny. It's okay.
Oh, okay.
Yeah.
Okay, I found the interesting question also from Imam Teguh. Okay, so is the recycling process in Taiwan is done by the private company or the government? Okay, and another question is how about the cost? Is it done? Is it supplied by the government or the company itself? Okay, yeah, that's the question, Professor.
张总经理，两个很有趣的问题哈。印尼的朋友想要了解说，这些废弃物的回收，工业废弃物的回收呢，是民间部门在做呢，或者是公部门在做？这是第一个问题。那第二个呢是说，例如说中台科技在回收这些废弃物的时候呢，那这个主要的这个钱啊是哪里来的？是污染物的生产者出的呢？或者是消费者或者是政府补助就是整个这个价格或者是整个金钱流跟物质流的问题麻烦你回答，谢谢。
好，首先针对那个回收回收，因为在台湾，因为基本上政府定游戏规则，法令规定，然后民间走自由竞争市场，所以资源回收都是 从民间来做，可是政府就是因为涉及到，因为废弃物资源化、回收跟处理还有废弃是一体两面，所以在法令里面有规定，就是要有资质，就是你要做资源回收或处理，你要取得证照，有这样的规定。那第二个就是费用的部分，台湾是采用污染者付费原则，也就是事业你产出的废弃物，那就事业要出钱。那焚化处理的费用多少，那政府不去定这个价格，就是由这个产生废弃物的事业跟处理端两个来议核这个价钱。那目前就是因为要看整个市场的处理容量以目前台湾的焚化炉其实只有处理事业废弃物的焚化炉只有4座，我们中台是第4座唯一有发电的也就是我们中台。那我们处理的费用目前一吨的处理费用，事业废弃物一吨处理费用是2万块台币以上，跟一般的都市焚化炉处理民间的垃圾一吨是2300，所以是有很大差别。因为2300的焚化炉是政府新建，然后民间代操作，所以相对费用会比较低。那像我们这种烧事业废弃物是民间投资、民间营运，所以相对成本就会比较高。以上。
Okay, maybe Professor Liu, could you, help us to translate the answer?
Oh, okay. It's a very interesting question, mainly for industrial waste treatment and disposal, as well as recycling and reuse. Okay, mainly it's done by private sectors on competitive basis. So it's like private sectors, they bid for the project to handle all industrial waste treatment, disposal, and recycling and reuse. Okay, so roughly speaking, in treating industrial waste by the Zhongtai Resource Corporation, the cost is about 20,000 NT per metric ton, okay, which is about $700 per metric ton. And one important thing is for private companies involved in this business, it has to be certified by Taiwan EPA first. So total, there are only 4 companies in Taiwan, certified companies in Taiwan in this business. However, only Zhongtai out of the total of 4 companies are involved in producing electricity from industrial waste in the process.
Wow, Zhongtai technology company is very cool. Yeah. Okay, so let's go to another question. The first from Trio Teguh Putra. Okay, first is how to ensure that the Zhongtai company has the good safety for the employee and also for the environment, and what is the standard that they use. Okay, and the second is from the process we can see that can you explain more that how to reduce the gas emission that discharge to the environment, and how to ensure that it is good to discharge or not hazard for the environment. Okay, that's.
好，张总经理，有2个问题。第一个问题是说，有印尼的朋友想要了解说，中台公司呢，怎么样子确保对环境的保全，还有对受雇员工的 健康安全的这个保障。第二个问题是说，在焚化或者是在其他的这个处理的过程呢，怎么样子确保废气它的排放呢，对于大气环境呢是没有不利的影响。谢谢。
这个是非常好的问题哈。其实我们中台本身我们也在推行 ESG。我们预计今年7月底我们会发行我们第一本的 ESG。那主要就是因为发行过程里面，我们内部有建 ISO 治安卫管理系统 ，ISO 45001。由制度化来保障员工的健康，因为员工是我们的宝贝，所以相对我们以安全为第一要务。所以我们员工整个操作过程里面，我们都有相关的防护设备，这是必备的。那另外就是有关环境确保的部分，因为我们焚化过程里面，我刚才提到，就是烧的话，固体烧完以后，大概80%都是气体。那我们在这一块里面，我们有很好的防治设备，多段的污染防治设备，然后还有这个24小时连续监控系统，可以从后端的状况来控制前端，做前端的调整。那这是我们最重要的一个项目。那另外在环境保护的部分，我们底渣啦、飞灰这些我们也进一步要把它做资源循环。那我们目前就是因为我们希望就是持续的能够做到零排放，所以在飞灰的无害化部分跟烟囱的碳捕捉，我们持续的在做相关的研讨，希望能够未来预计也挑战2030年净零碳排的这个目标。
Okay, this is an answer from GM Zhang regarding the protection of the environment and the safety of employee. Zhongtai Corporation actually values ESG, environment, sustainability, and governance. Actually, the company is going to release the first ESG report, the CSR, in this year. So the company basically adopts ISO 45001 system. Okay, so the approach is to use systematic approach to protect the environment as well as the employees who are the precious assets of the company. Okay, and the second is regarding the air pollution control devices following the incinerator and pyrolysis reactor. You find scrubber, you find backhouse, EP, so that NOx, SOx, in particular metals, are all effectively removed. And actually, the company also set up, as required by the government, a 24-hour continuous emission monitoring system. Okay. So the gas pollutants control is in good condition. Moreover, the company is looking into better or value-added reuse of button ash and fly ash. In the meantime, the company is studying the control of carbon dioxide in the STIC, okay, so that to meet the 2030 zero emission target. Yeah, this is the answer.
Okay, thank you, Mr. Chang and Professor Liu. So maybe this is the last question about the regulation in recycle recovery of waste. Okay, how about the application of the ban and fine and the sanction regulation in Taiwan?
对，张总经理，那印尼的朋友想要了解说，台湾在这些工业废弃物的回收或者是处理呢，它的一些罚则大概是怎么样？比如说违法，那它是不是会被罚款？是不是会被停工？是不是会有一些 刑事的责任，他们想了解说法规方面呢怎么样子在做规范。
好，因为废弃物的处理法规法规是非常重要的。那台湾就是因为虽然有很多的处理单位，可是难免还是会有违法乱倒的行为。所以台湾的法令在去年有修订，就是这个延伸这个产研事业的责任，就是产研事业它不是单单把废弃物委托给别人处理就不用理了，它要有应尽的责任，他要去追踪，就是废弃物委托假设他委托给我们中台资源，那他要定期到我们中台资源来看我们有没有妥善处理，那做成记录，用这样的追踪，就是产研跟处理端彼此之间的相关的互动，要有这些的资讯佐证。
好。It's a very good question. According to Mr. Zhang, okay, when it comes to industrial waste treatment and disposal, laws and regulations are very important. However, even in the presence of very stringent regulation and fine, okay, still you find inappropriate treatment and disposal in Taiwan, okay, now and then. That's why starting from last year, the laws and regulations in Taiwan are amended to emphasize the EPR, extended producers' responsibility. So, for example, TSMC, the world's leading semiconductor company, asked on lease Zhongtai to treat the waste produced in TSMC. Still, TSMC will be held responsible to trace and to ensure that the waste, okay, will be treated nicely and no breakup of the laws or regulation. Okay, so the producer's responsibility is to carry out routine checkup and to make records report to the EPA, so that just to make the proper treatment and disposal more reasonable and more practical. That's the answer from Mr. Zhang.
Okay, thank you very much, Professor Liu and also Mr. Chang. So I think all the questions have been answered. So thank you very much once again, Mr. Chang, for the very nice presentation and so many new information about the regulation and also the treatment process of the waste in Taiwan. Okay, so I will give it back to the host, Bu Wawa. Yes, thank you.
Yeah. Thank you very much, Jenny. Thank you, Mr. Amos Chang, and also Professor Liu. Thank you very much for the explanation. But before I close, maybe I would like to talk in Bahasa a little bit about what Professor already mentioned, because some of terminology maybe also is not very familiar to our interpreter. So, Bapak dan Ibu mungkin yang dari DLH dan juga dari pemerhati lingkungan, bahwa tadi yang sudah disampaikan berkaitan dengan proses yang terjadi di recycling company ini adalah mereka menerima berbagai limbah dari berbagai sumber. Kemudian tadi ada beberapa proses mungkin yang menarik untuk Bapak dan Ibu sekalian adalah proses yang tadi dijelaskan, ada dengan insenerasi, kemudian ada dengan pirolisis, terus kemudian juga ada beberapa proses tadi tentang e-waste recycling. Ini yang sedang banyak kita bahas juga, dan tadi sudah disampaikan bahwa kalau untuk mengontrol dari polusinya mereka menggunakan ada scrubber, kemudian ada electrostatic precipitator, itu yang mereka gunakan, kemudian baku mutunya juga ada, dan mereka semua menerapkan extended producer responsibility. Jadi itu mungkin yang harus kita mulai kerjakan di Indonesia, karena sebetulnya aturannya sudah ada, hanya saja extended production responsibility di Indonesia itu akan baru diterapkan nanti pada tahun 2030 walaupun peraturannya sudah keluar di tahun 2019 kemarin. Mungkin itu yang bisa kami sampaikan. So thank you very much for all of the distinguished speaker and also distinguished professors. It's a very fruitful discussion, and before we close our webinar, we would like to take a pictures together. So please, all of the participants, maybe you can turn on your video. Yeah, we have 90 of the participants, so 5 slides. I think, if Mbak Dewi, you already start to take the pictures, Mbak Dewi.
Yeah. Yes, Bu Wawa, I will.
Yeah, you can count from the first slide until the last slide, okay?
Yes. Okay. For the first page, 1, 2, 3, and then the second page, third page, and for the last page.
Okay, thank you very much, Mbak Dewi. Pak Rektor, thank you for attending this activity until the end. So hope that can see Pak Rektor again in the future. Thank you very much for coming. And Mr. Amos Chang, Professor Liu, and all. So this is the end of our meeting today. So we can still in the Zoom, but of course the activity informally is already finished. So thank you very much again, and hope that we can meet in another occasion, especially for transfer knowledge from Taiwan to Indonesia and also the collaboration for the next future. Thank you very much. Bye-bye.
Thank you, everyone. Thank you so much. Thank you, Mr. Chang.
Thank you very much.
Thank you,
We have Mbak
Pak Kun.
Yanti in here. Mbak Yanti, are you still there? Yanti. Mbak Yanti. And also some friend, I think. Pak Welly is also in Tainan, Professor Liu.
Oh, yeah?
Yes, already take for the doctor degree there.
So Paweli should come visit me, okay?
Yeah.
In National Chen Kong?
Yes, National Chen Kong,
I see,
under Professor Lin.
Lin Caifu.
Yes, Sir Fu Lin. Yeah.